Here's the mixer design. The topology we are going to use is single-ended bipolar junction transistor Gilbert mixer. We begin by choosing transistor that will be used in this topology. Here's the list of transistors acquired from the DigiKey website, and we sorted by the frequency from high to low. And for this application, it requires a frequency of 2 GHz, and the transition frequency should be higher than 12 GHz. We also want a higher gain and a lower noise figure for this application. From all the options shows here. The BFP740 has a relative high gain up to 31 dB and a low noise figure of 0.5 dB. According to the data sheet, we find that for the transistors to function properly, the VBE has to be biased at 0.8 millivolts, 0.8 volts. And we choose the transistor accordingly to bias. We choose the resistors accordingly to bias the transistor. The capacitor used in the bias node will prevent high frequency noise and the feed-through signals to affect the operation point. After building the mixer, we ran a test to get a conversion gain. Here's a plot of conversion gain versus LO power. We can see that the conversion gain reaches its maximum value at negative 7 dBm, and that's the value we choose for our LO power. And here's a plot of conversion gain versus RF frequency. The conversion gain increases with RF frequency until 4.5 GHz, which we found it hard to explain. Here's the harmonic balance simulation. The largest frequency component are 150 MHz and 2.85 GHz, and the other frequency components are very low compared to these two. And the IP3 output is 3.894 under the bias condition, which provide us with So here's our test bench. We have the IP. This is our second test bench. We have the IPL3 and the harmonic balance simulation and the N-tone port for the RF input. To design the filter, we use ADS filter design tool. Here's the 4-pole maximum flat filter we designed. We can see that the bandwidth of the filter is around 50 MHz. Further bandwidth of IF will be tested in the combined design. The red box is the impedance matching network we designed using the Smith chart tool. And here's the harmonic balance simulation for the combined design. You can see that all the higher frequency components are completely being filtered out by the filter, and the IP3 output is 8.066 for this application. And here's the IF3 bandwidth. We run the S parameter simulation, and we can get the 3 dB bandwidth from 143 MHz to 160 MHz, which is around 18 MHz.